Swayam Prabha. Digital India. Educated India.
So, last class I have discussed about the semi-infinite beam subjected to a concentrated load. Now, today I will first solve two example problems. One is infinite beam subjected to concentrated load P, and one semi-infinite beam subjected to one concentrated load P. So, first problem that we will discuss is it is an infinite beam. So, this is an infinite beam subjected to a concentrated load P equal to 20 kilonewton, and as I mentioned, the point where the concentrated load is applied in case of infinite beam is considered as 0, x equal to 0 point. So, this is x equal to 0 point. Okay. So, it is in case of infinite beam. So, this is infinite beam. Okay. So, the width of the beam is 0.5 meter, that means B is equal to 0.5 meter, and height of the beam h is equal to also 0.5 meter. So, it is a square cross section. Now, we have to determine two things. One is settlement at x equal to 0, and another is settlement at x equal to 1.5 meter. Now, in this case it is a settlement. So, as I have already discussed that whether it is a left side of the loading or right side of the loading, it does not matter, because the settlement will remain same. So, in case of concentrated loads in infinite beam, settlement will be same whether it is the left side of the loading or right side of the loading. So, the settlement and bending moment are same, but the slope and the shear forces are opposite. So, now the k value which is given, basically it is a k 0 which is given 15,000 kilonewton per meter square per meter. Okay. And so, that means my k is equal to b into k 0. So, b is equal to 0.5 and k 0 is 15,000. So, this value will be 7500 kilonewton per meter square. Okay. And EI value is directly given, and that is 10 to the power 6 kilonewton per meter square. Suppose in this particular problem the EI value is directly given, but in other cases the E will be only given, that means elastic modulus of the beam material, but I you have to calculate. So, you know that I is equal to 1 by 12 B h cube. So, here you know the B value, you know the H value. So, you will get the I, and if you multiply I with E, you will get the EI. So, that is also another option. So, now here these are the properties are given. So, we know the equation for deflection for infinite beam subjected to concentrated load is P lambda by 2 k, and then e to the power minus lambda x cos lambda x plus sin lambda x. Okay. So, that means it is a to the a lambda x. Now, at x equal to 0, that is our first case. So, y will be equal to p lambda by 2 k only, because at x equal to 0, the sin 0 is 0, cos 0 is 1, e to the power minus 0 or 0 is 1. So, it will be p lambda by 2 k. So, we have to calculate the lambda value. A lambda value is 4 root k 4 E I. Okay. So, this is 4, k value is 7500 divided by 4 into 10 to the power 6. Okay. So, this is 0.21 unit, lambda unit is meter to the power minus 1. So, I can write that y at x equal to 0 is p is equal to 200, then lambda is equal to 0.21 divided by 2 into 7500, which is 2.8 into 10 to the power minus 3 meter. So, that is 2.8 millimeter. So, this can be positive also, negative also, depending upon where you are calculating the value. Definitely at x equal to 0, settlement will be positive. Positive means the downward settlement. So, and this sign will automatically come where you are taking the value based on the your x value. So, now the next problem, we will get that y at x equal to 1.5 meter. So, at x equal to 1.5, the lambda x value is equal to 0.21 into 1.5. So, this is 0.315. So, 0.315, if I multiply it by 180 degree divided by pi, because this lambda x, when we will use it in sin and cos, we have to convert it to degree, because the lambda x is in radian. So, we have to convert it to degree. So, this value is 18.05 degree. So, I can write that a lambda x equal to 1.5, that is equal to e to the power minus lambda x. So, e to the power minus lambda x is 0.315, then cos 18.05 degree plus sin 18.05 degree. Okay. So, this value is coming out to be 0.92. So, y at x equal to 1.5 meter. So, this will be p lambda by 2 k on this term. So, p is 200, lambda is 0.21 divided by 2, then 7500, then e to the power lambda x. Oh, so that part I have already calculated. So, this e to the power lambda x means 0.31 a lambda x I have already calculated. So, I have to multiply with 0.92. So, this value is coming out to be 2.57 into 10 to the power minus 3 meter, which is 2.57 millimeter. So, this way I can calculate, or we can calculate the bending moment, shear force or slope at any point from the loading, either it is right side or left side. So, all the expression, as I have already discussed, all the expressions are given for the right side of the loading, that means x is greater than 0. But if you want to determine the values at left side of the loading, that means x less than equal to 0, then you have to apply that plus minus sign as I have discussed. So, next problem that I will discuss is for semi-infinite beam. I will take the similar type of problem, but now the beam is semi-infinite beam. So, this is a semi-infinite beam. So, it is infinite in this direction. So, here it is in the free end beam. So, this is free end. Okay. So, that free end is A point, or it is, we can say it is a O point, and we are applying one concentrated load P, which is 20 kilonewton. So, which is at a distance of 0.75 meter. Okay. So, that means A distance. So, this is, I can say this is A. So, A is 0.75 meter. So, this point is capital A where the load is acting, but in this case for the semi infinite beam, that free end is considered at x equal to 0. Okay. So, now here the again K 0 value is given 55,000 kilonewton per meter square per meter. Then the cross section area of the beam B is equal to 0.25 meter and H is equal to 0.2 meter. Okay. So, now we can say that K is equal to B into K 0. So, this is 0.25 into 15,000, that is equal to 13750 kilonewton per meter square. So, E is given here 10 into 10 to the power 6, 10 into 10 to the power 6 or 10 to the power 7 you can say, and I we can calculate 12 BH cube. So, this is 1 by 12, B is 0.25, then H is 0.2 to the power cube. So, this is 1.67 into 10 to the power minus 4 to the meter to the power 4. So, EI will be equal to 1.67 into 10 to the power minus 4 into 10 into 10 to the power 6. So, this is 1.67 into 10 to the power 3 kilonewton meter square. So, the lambda value I can calculate 4 root of k by 4 EI. So, 4 root of k is equal to 13750 and EI value is 1.67 into 10 to the power 3. So, this value is 1.198 meter to the power minus 1. So, as I have already discussed in case semi infinite beam, that if this is the P which is acting at a distance of A. So, first we have to calculate MA and QA for free end, then you have to apply end conditioning forces such that the net moment and the shear force will be 0 at free end. Okay, I have discussed. So, that means here we have to apply one moment, that is P 0 A or P 0, and we have to apply concentrated load P 0 and moment M 0. Okay. So, now this expression of this P 0 I have already derived. The expression of P 0 is 4 lambda M A plus Q A, and expression of M 0 is equal to minus 2 lambda by 2 lambda M A plus Q A. Okay. So, what is M A and Q A? MA is the moment induced due to the load P if this beam is considered as infinite beam. QA is the shear force induced due to the load P if this beam is considered as infinite beam. But now it is, but actually it is not an infinite beam, it is a semi-infinite beam. So, at free end we have to apply end conditioning forces such that the MA and QA will be vanish. Okay, because that is the end condition, that free end condition, moment should be 0 and shear force should be 0. So, now first you have to calculate the MA. The MA due to the load P will be equal to P divided by 4 lambda C lambda A. Okay. So, I am calculating one how to calculate I am showing the one calculation that how to calculate C lambda A, because C lambda A will be equal to e to the power minus lambda A, then cos lambda A minus sin lambda A. Okay. So, lambda A equal to lambda is 1.198, A is equal to 0.75. So, this is equal to 0.8985 and that we have to convert into degree. So, this value is 51.51 degree. Now, if I calculate C lambda A, that will be e to the power minus 0.8985 cos lambda A is 51.51 minus sin 51.51 degree. So, this is equal to minus 0.0653. Similarly, we can calculate d lambda A similar way, that is equal to 0.253. Okay, because d lambda A is e to the power minus lambda A into cos lambda A. Similarly, I can calculate A lambda A, which is equal to 0.572, and I can calculate B lambda A also, which is equal to 0.32. So, similar way that I have calculated the C lambda A, I can calculate D lambda A. Similarly, A lambda A is equal to e to the power minus lambda A into cos lambda A plus sin lambda A, and B lambda A is equal to e to the power minus lambda A into sin lambda A. So, if I put all these values, then I will get A lambda A, B lambda A, C lambda A, D lambda A. So, now the MA value is P into 4 lambda by C lambda A. So, MA will be equal to P is equal to 20, then 4 lambda A is 1.198, then C lambda A is minus 0.053, it is minus 0.0653. So, MA is minus 0.273 kilonewton meter. Okay. Now, similarly, I can calculate QA, which is equal to plus P0 d lambda A. Now, why it is plus P0? Because as I mentioned that if you are calculating any value for concentrated load left side of the loading, then for shear force and the slope this sign will be opposite, but what are the equations are given, that is for right side of the loading. So, here you can see that A point is this point free end. So, I should write this is free end point is A. Okay. So, free end point is left side to the loading. So, here shear force will be opposite sign and the slope will be opposite sign. So, that is why it is plus P 0 by 2 d lambda A. So, it will be P 0 is 20 divided by 2. Now, d lambda A, d lambda is 0.253. So, 0.253. So, this value will be 2.53 kilonewton. Okay. So, now if I have calculated the MA and QA, that is due to this point load P, because this MA is due to this point load P at a distance A. So, and we are calculating left side to the loading. So, that is the expression of MA, P lambda by 4 P by 4 lambda into C lambda A, because these expression I have already derived for concentrated load, concentrated moment. So, from there I am getting this value, but Q will be the opposite sign because it is right side left side to the loading. So, now P 0 will be equal to the P 0 expression. If I put this value, this will be 4 now lambda is 1.198, then MA is minus 0.273, then plus QA. So, QA is 2.53. So, this value is 8.81 kilonewton. Similarly, M0 is minus 2 by lambda, lambda is 1.198, then 2 into lambda 1.198 into MA minus 0.273, then QA is plus 2.53. So, this is equal to minus 3.13 kilonewton. So, now we have calculated the end conditioning forces P 0 and M 0. So, and these values are 8.81 kilonewton and minus 3.13 kilonewton respectively. So, now finally, I will got this, I will get this forces. So, P is equal to 20 kilonewton and this distance is A is equal to 0.75 meter. Now, we have a P value P 0 is 8.81. So, P 0 is acting here, that is P 0 which is 8.81 kilonewton. Okay. And we have M 0 and M 0 is negative. So, that is why I am giving this sign. So, M 0 is 3 point, let me check. So, M 0 is 3.31 and which is minus 3.13 kilonewton meter. So, as I have discussed that clockwise moment to the left side is positive and anti-clockwise moment to the right side is positive, but here it is negative moment. M 0 is minus 3.13. So, that is, and it is acting in the left side. So, that is why it is shown as a anti-clockwise moment. Okay. So, now I want to calculate the settlement at x equal to 0. So, so that means I have to calculate the settlement at x equal to 0 and that x equal to 0 means this is x equal to 0. That means at the free end. What is the settlement at free end? X equal to 0 means free end. Okay. So, now we have 3 forces, basically 2 concentrated load and 1 concentrated moment. and that is also acting in anti-clockwise direction. Okay. And so, because of these three forces, what is that settlement at free end, that we have to calculate. So, now the one by one I am calculating this value. So, for P0, which is at x equal to 0. So, P0 at x equal to 0. So, that means the settlement due to P is P lambda by 2k into A lambda k lambda x. Now, at x equal to 0, A lambda x equal to 1. So, y will be P lambda by 2k. So, that means here due to this P0, this will be P0 lambda by 2k. Then, because of this moment also, I can get m0 lambda square by k. Okay. So, into b lambda x plus, so here also I am writing a lambda x. So, later on I will put a lambda is equal to 1. So, but I am now writing general equation. So, for this concentrated load P0 lambda by 2k A lambda x, for this concentrated moment m0 lambda square by k b lambda x, and then for this moment P this concentrated force P lambda A lambda by 2k into A lambda x. Okay. So, now I can write at x equal to 0, because P0 at x equal to P0 is acting at x equal to 0, and I want to determine the y at x equal to 0. So, I can write P0 lambda by 2k into 1 plus this is 0, because b lambda x is equal to e to the power minus lambda x, then sin lambda x. Now, at x equal to 0, this b lambda x will be equal to 0, because sin lambda x is 0. So, sin 0 is 0, and then this is p lambda by 2k into x is a is 0.75 meters. So, this will be a lambda a. So, I can write that P0 is 8.81, lambda is 1.198 divided by 2 into 13750, then plus 0 plus P is equal to 20 kilonewton into lambda is 1.198 divided by 2 into 130750. A lambda A, we have calculated, the A lambda A is 0.572. So, that we will put 0.572. So, this value is coming out to be 0.88 millimeter. So, this is the settlement at x equal to 0 or free end, that is 0.88 millimeter. So, this way we can calculate the settlement or bending moment or shear force or the slope at any point, but we have to consider these three forces. One is the P, which is the external force, concentrated load is applied. Another two are the end conditioning forces to make the net bending moment and the shear force at free end 0. Clear? So, that means we can calculate what would be the settlement at P point, at the point where the load P is acting. So, that also we can calculate. So, in that case you consider the point is right side to the P0 and the moment, and the point is just below the P. Okay. You can calculate any point right side to the point P also. So, anything you can do by using these equation. Now, remember that one thing I want to mention here, the second term is coming 0. So, that is why we can just make the whole term 0, but you can see here m0 is written. So, m0 when you write, you do not write 3.13. If suppose it is not 0, that means b lambda x is not at x equal to 0, it is maybe some value, but in such case m 0 should be minus 3.13, because this is a general expression and here the m 0 is clockwise moment. Okay, because when I derive the expression for moment, so those expressions are valid for clockwise moment, but here your moment is anti-clockwise. So, we have to put minus sign here. Okay. So, that is why when you put m 0, do not put 3.13, because that is, if the moment is clockwise, then it will be 3.13, but the moment is anti-clockwise. So, here you have to write minus 3.13, but in this case it is 0. So, you are not thinking about the value of m 0, but if the b lambda x is not 0, then remember that because it is minus, m 0 is minus. So, you have to put minus value. Clear? So, next class I will discuss the beam with finite length, then I will discuss about the beam resting on 2 parameter model, and then I will discuss about the finite difference method in the coming classes. Thank you.